Benson Colella works to reclaim nutrient resources from human waste as an engineer at Wasted, PBC, in Burlington, Vermont. In this role, Benson treats source-separated urine for use as an exceptional quality soil amendment and holds in chemical engineering from Worcester Polytechnic Institute and has experience working on small farms.
Thank you.
Benson.
All right, I have a pretty simple talk just explaining the toilets that Wasted offers and how we use those to collect urine for beneficial reuse. So our vision here at Wasted is to catalyze circular sanitation and change the way people think about waste. And our mission is to build the most... Our mission is to build the most scalable, sustainable, and lovable sanitation business in the world by delivering on our promise of potties with purpose. So we are primarily a portable restroom business. We operate with 25 employees between 2 markets. In Burlington, Vermont, where the regulatory landscape allows it, we collect pee from our toilets and make that into fertilizer. In Burlington, we have 3 trucks and service about 350 potties per week. In Boston, Mass, as you've heard today, the regulatory landscape is not quite ready to make fertilizer from urine, but we're scaling our operation there in anticipation of turning collections on real soon. So in Boston, we have 4 trucks and service about 1,350 toilets per week. So our thesis, like a lot of the organizations here, is that urine is more valuable as a resource when it's kept separate from waste. But as you all know, urine is pretty bulky, it's heavy, so it can be pretty expensive to move it around. Well, we already have that problem because we're a porta potty business, so it just makes sense for us to keep that waste separate in the truck, and bring it back to our facility. So we are trying to scale urine collection, and to scale urine collection, we want to scale our porta potty offering. So we're scaling porta potties by offering a differentiated service. We offer toilets that are greener and cleaner than our competitors. So folks choose Wasted because our toilets smell good and are clean, and also because of our mission. We have a sustainable toilet paper. It's bamboo-based, a biodegradable portable toilet additive, that's the blue goo, and we offer reduced carbon emissions due to the flat packing of our modular toilets. So we're scaling to collect pee, and we're now at the point where we need more pee. We're generating revenue from fertilizers, so we need more pee, and that's a great problem to have, which Rachel will speak to a bit more in her presentation. So we collect most of our pee through these standing urinals in our portable toilets. This was just an idea last year, but it's now become a reality, and we've scaled our portable toilet urinals 5-fold with these new urinals. These are injection molded and they're modular. We can snap them into our existing porta potties with no other modifications, so that makes it very easy to adopt. And these have a one-way valve between the urinal bowl and the tank, preventing smell from flowing back up. And they have about a 7-gallon capacity, which allows us to collect pee over the course of 2 weeks without pumping out. So we estimate that we collect, or we have previously measured that we collect about 3 gallons per porta potty pump out. So if that rate continues, we can collect 17,000 gallons of pee in Burlington next year and 100,000 gallons in Boston once we're allowed to begin collections in Boston. So our standardized offering for permanent or semi-permanent fixtures is our donation station. And here we have some stations that were installed at Marino Park in Providence. So these toilets have a dry conveyor belt flush toilet right there. So it's it's waterless, and it's completely off-grid. It's solar powered. And the good thing about these toilets is that they collect from both standing and sitting peers, whereas the urinals in our porta potties are a bit of a compromise. This toilet on the ground collects from anyone who stands or sits, no matter how you use the bathroom. This is also, of course, accessible. It's accessible by a wheelchair, and just like to highlight some engineering here because it was a unique challenge. This toilet being accessible by a wheelchair and being built fully above ground had to have some pretty interesting plumbing. Since you all know pee flows downhill, there was nowhere for it to go beneath the toilet. We didn't have much room for a big tank. So the solution we arrived at was to pipe the pee first into this small tank, then pump it up into a larger tank using a solar-powered pump. So this large tank has a 100-gallon capacity, and it has an ultrasonic sensor in the top, so we can measure the volume of waste at any time and only send out our trucks once it needs to be pumped. So with this big tank and the remote monitoring, we're able to more efficiently pump out these toilets as opposed to porta potties, which need to be pumped out every week. We offer that same conveyor belt toilet for custom settings. If a customer has their own structure or wants their own structure built, we can work with them to install a conveyor belt toilet there. And the benefit here is usually increased collection capacity as well, because more often these pipe to a 250-gallon tote, so we only need to pump that out once or twice a year. And if anyone in Massachusetts is interested in these toilets, come reach out. So our last method of urine collection is the VIP trailer, and this is a high-end restroom trailer for events like weddings and concerts. This again has the dry conveyor belt toilet and running water, so it's great for settings where people might not want to use a portable toilet. So all of these toilets are in service of our vision, which is to change the way people think about waste, and we lean into that from a few angles. We have educational graphics in our porta potties and our structures, really letting customers know that we do make resources out of their waste, or we do recover resources from their waste. We also provide customers with impact reports, letting them know the resources saved or diverted by choosing wasted. And we offer a product with a story. I didn't really get into it, but we sell WeBloom, which is a solid phosphorus fertilizer made from the urine we collect. So customers can then buy back their nutrients as WeBloom to use in their gardens, which I think is a great demonstration of circularity. So customers love going with wasted. They love not only our higher end service and offering, but also our environmental mission. So we're proving that, yes, people outside of our peace cycling circle can see urine as a resource. Thank you. Yeah, any questions?
We can take like maybe one or two questions, and then we'll go on from there.
We have a sample of WeBloom here if anyone wants to check out the packaging. It's in our urine fertilizer exhibit. Or it's here right now. But, yeah.
Arthur.
What, oh, sure. How does the flat packing work? Do you have any pictures? I'm just curious.
Yeah, I don't have it.
I'm just wondering about it.
Yes.
Thank you.
Because it has a tank.
So each of the 4 wall panels comes apart and they slot one in front of another inside of one toilet. And then all the tanks stack one on top of another as well. So you can fit 4 tanks in one toilet and 4 sets of walls in one toilet. So it only gets a little cumbersome with the urinals that don't quite fit in there. You gotta pile those up somewhere.
Right. So you would probably just use that. Oh, the mic is on. You couldn't tell.
There you go. That's better. Right. So you would probably only use it for like large events where you're bringing lots of toilets somewhere.
Exactly.
Yeah. Exactly. Cool. That's awesome.
Take one more.
Yeah.
I'm wondering if it would ever be possible to retrofit existing porta potties.
Yep, and that's something we do. We bring that conveyor belt toilet to people's own outhouses, and pretty much just by cutting a hole in the wall and patching up any holes in the floor, we can install that toilet because it flushes backwards into a larger tank.
You know, I'd love to see these in my town, but I know that there's an existing sort of septic, companies that it's a very small town, so they're making their living bringing porta potties to different things, and we don't want to erode their ability to make a living. Good, thank you.
And I will add that that is also a way that Rich Earth does our portable toilets, is we retrofit other more common toilets. Yeah. Thank you, Benson. Is this? Great. Is Diana next? Wonderful. Thanks for your patience with the microphones. I know it's very confusing. All right.
Yeah.
Next up, we have Diana Yousef. And I need. Nope.
Salika again.
All right. And I'll start talking because there's a lot to say here. Diana, PhD, MBA, MA, is a serial entrepreneur with 10 plus years experience commercializing technology for social and environmental impact in the developing world. Formerly, she consulted for McKinsey, co-founded IFC World Bank's Life Sciences Investment Group and the United Nations Inclusive Markets Incubator, and was a seed stage VC with Battelle Ventures. She co-founded WeCyclers, a social venture to clean up urban slums and create recyclables supply chain linkages in Nigeria. Also co-founded Immerse Global, a Stanford spin-out to develop atmospheric water capture technologies, and co-founded SAC Sci Solar, an say it one more time?
I was not a fan of the name, but they called it Saxy Solar.
Saxy Solar, thank you. An MIT spin-out.
Branding.
An MIT spin-out to develop revolutionary new materials to lower the cost of solar energy. She is a former protein biochemist, AB from Harvard, a PhD from Cornell, and holds an MBA and MA in International Development from Columbia. She serves as an advisor to the TED Fellows Program and a co-founding council member for NASA and USAID's Launch Accelerator. She is founder and CEO of Change Water Labs. Welcome, Diana. Diana.
Wow, okay. I was expecting that to be excerpted. Can you guys hear me? Can you hear me?
So the
Okay.
mic is for the people.
Oh,
listening.
okay,
You
great.
have to project
All right.
to the room.
All right,
Pretend
but
like
I'm
they're not
short.
there
Okay,
for
yeah, I'll
sound
do that.
purposes.
Okay, great. So I'll just apologize up front that, I was a little surprised to get U.S. interest for our technology because I figured the first adopters of our technology were going to be, outside of the U.S. where the alternative to our toilet would be no toilet. So I have a little bit of a global story. So I might be telling you things that maybe don't exactly relate to the Cape, but sort of paint the picture of how we got to where we are. So Change Water Labs is a climate tech venture that has invented a technology to evaporate human waste. So where this came from is that a number of years ago, I was consulting to NASA looking at how to recycle wastewater on the space station. And what I realized is that just like space, there are a lot of places here on Earth that have no good ways to get rid of sewage waste. So to demonstrate that, 50% of the world's population, that's 4.2 billion people, lack access to safe, clean toilets. And that's largely because they live in places where they can't hook up to water or sewer plumbing, so they can't flush. And on top of that is another demonstration that we're not great at dealing with sewage waste. 80% of human waste is dumped into the environment untreated. The U.S. alone contributes 1.4 trillion gallons per year of raw sewage into our oceans every year. That's the equivalent of every American dumping 12 gallons of sewage into the ocean every day. So poor sanitation poisons people and the planet, contributing to 80% of infectious disease spread and 1/3 of nitrogen pollution of our coastal waters. And that nitrogen pollution in our oceans contributes to mass die-offs of marine life, fuels huge toxic algae blooms like you are all aware of, and also smothers 2/3 of coral reefs. The other thing that maybe is a hidden problem is that the degradation of this, untreated sewage into our environment just it emits the worst greenhouse gases. So essentially, that includes methane and nitrous oxide, which are respectively 30 and 300 times worse than carbon dioxide. So to give you sort of like what the future looks like, by 2030, 2/3 of us are going to be, or more than 2/3 of us are going to be living in urban or coastal communities. These are densely populated communities, but there isn't going to be a sufficient amount of infrastructure expansion, and we're facing increasing water scarcity. So the reality is that if we look at 2030, 2 billion people living in urban areas, that's 1/3 of city dwellers, are going to have a non-sewered toilet option. So the reality is, and I think most of you know this, is that sewered sanitation is just not going to be a feasible option for most of the non-sewered communities in the world. And so as a result, it's not a huge surprise that $19 billion per year gets spent on non-sewered sanitation, but none of the current options do a good job of saving our oceans, cleaning our oceans, or curbing greenhouse gas emissions, climate change. So, so when I was at NASA, I kind of came up with this idea for a toilet that could make waste literally disappear. So that would mean no dumping, no discharge, no pollution, no flushing, no frequent waste collection. And the insight came from the fact that human waste is mostly water. It's 95% water. So instead of flushing water with more water, why don't we just evaporate it? So we came up with the iThrone. It's a waterless, sewerless toilet that rapidly shrinks human waste. So the way that it does it is that the iThrone collects solid and liquid waste in bags made of a novel breathable material that we call shrink wrap for crap. These, that's the branding. I had nothing to do with Saxy Solar, but shrink wrap for crap, that was all me. So, so anyway, yeah, and we actually do separate, we collect liquid in one bag and solid in the other bag. And then these bags will quickly soak up the liquid water content of the waste, and by pulling it through the membrane, convert that liquid water into pure molecular water vapor. So essentially, that's like evaporating waste, but without needing heat to do so. So the effect of that is that we can make 95% of collected waste disappear in just one day. By dehydrating the waste so rapidly, we cut off the microbial conversion of that sewage into greenhouse gases, and we can use those dried, separated waste streams. They can either be composted or converted into bioenergy, biofertilizer, or other organic outputs, which is, I think, what you all are interested in. So, so basically, the iThrone is a toilet that gets rid of waste fast, but without water flushing pipes or pollution. The only thing that comes out of the iThrone is pure molecular water vapor. Because we don't need a hookup to existing infrastructure, that makes the iThrone easier and cheaper to install and service, and generally just cleaner for the planet. So if you're looking at how the iThrone compares to existing alternatives, it checks off all the boxes for waterless, sewerless, zero discharge, low cost, low maintenance toilets, and it's literally the only toilet that makes waste disappear. So the intended uses, or what we think that we can apply this waste shrinking technology to, are for drop-in, sort of compact drop-in sanitation in non-sewered urban areas, as a sort of zero discharge septic alternative for coastal communities, for emergency sanitation, and for water-saving sanitation in dry regions. We've run 2 pilots over 2 years, serving greater than 16,000 uses, and what we've been able to show with those pilots is that the iThrone has achieved a 97% elimination of collected waste. We can run them 100% off-grid because the power consumption really, solar is sufficient for the power consumption. It's really just running a fan. They're 500 to 300 times cheaper to install than comparables or alternatives, and they're 30 to 100 times cheaper to service. So when you think of the iThrone in terms of its impact, just one iThrone, just in a year, just one iThrone has the ability to protect or to reduce disease exposure for a community of 1,000 people, conserves 1,000 bathtubs worth of water per year, eliminates 24 bathtubs worth of sewage, and avoids GHG emissions equivalent to the burning of 125,000 pounds of coal. That's just one iThrone. So we're currently working on a deployment of up to 100 iThrone porta potties for the city of Santa Fe, New Mexico. They found us on a random Google search, which was great email to get, like, during my Christmas break, to sort of find this inquiry from the city of Santa Fe. They were looking for an alternative of sort of a drop-in sanitation solution to accompany the build-out of 100 tiny homes that they're going to use for transitional housing for the homeless. And they couldn't figure out how to not blow up their budget by a factor of 1,000 and sort of extend their timeline to permitting by at least 2 years. If they had to get a water septic permit system for each of those houses. So they reached out to us, and we hadn't had a porta potty version of the toilet. We'd had the installed versions in Panama and the sort of quasi-septic version in Uganda, but we converted it into, or we redesigned the porta potty, or we redesigned the iThrone to fit into a porta potty. And so we've actually got one of these units that by the end of this week should be running in over in Greentown Labs in Somerville. If you ever find yourself in Somerville, we have a climate chamber where we can mimic the different environmental conditions. So that's kind of our next frontier. We have a team that combines 50 years experience in clean tech and hardware engineering, sales and marketing, venture investing, and international development. And we all have a joint mission to get safe and sustainable sanitation to more people in more places at lower cost.
Amazing, thank you.
Take this?
Take the two.
Yeah.
Take just a couple of
Can you guys hear me, or does this work?
All of them,
Okay.
for all of these.
Thank you. That was fascinating. You said that you do have some waste, right? So how is that managed? How much is that at the end of, let's say, a year or a month?
Yeah. So we originally spec'd out the iThrones to sort of serve 1,400 uses before the bags had to be changed out. We're actually finding with our Panama pilot that we're running them, so 1,400 uses is basically 50 uses per day for 28 days. We're finding that we're running them 3 and 4 months before we have to swap the bags. The bags are, I think, 50-liter capacity, but we don't actually, the urine, we pretty much eliminate most of that. And the solid is, we have it, actually, when we're changing it out, we haven't had like a full bag. I don't know how much that is in pounds, but I think, if a 50-liter bag is like that big, we're filling it up like half. So did that answer your question? So basically, it looks like we're able to run these for, especially for households, maybe like with a change out once a quarter. And they're meant to be, 50 uses per day, for, those, that intensity of usage. Did I answer the question? Oh, okay.
Like, you have a company that comes and
Oh,
takes
right.
it? Do you use it for
Sorry.
fertilizer? Where?
Yeah, so
Who does that?
it sort of, the way that it's serviced and what happens to the waste is sort of it's whatever the local partner is allowed to do. We can't be prescriptive about that. So in Panama, they've hired somebody with a pickup truck who comes in and picks it up. We haven't gotten the permission to do anything other than landfill it, which isn't like our favorite, obviously, but it's a lot less waste. It's not running into anything, so yeah, for New Mexico, the idea is to either hire a certified composter or a certified incineration service to deal with it. But so it's not at we sort of can plug into whatever's allowed, but yeah, it would have to be whatever's allowed, but it can go into, more the circular pathways, or it can go into the less circular pathways. So we're targeting, we've got 3 models. Oh, sorry, the question was, what's the cost of the unit? So we're targeting 3 models that are gonna, the sort of the lower end, which is sort of more competing with composting toilets, probably gonna be priced around $800. There's a smarter version, or a smartest version, that's like more like $3,000, and that's more for like fleets and commercial operators. And then I think there's kind of be like a medium intelligence version that's in the middle. And so the difference between those is going to be the just sort of like how intelligent the toilet is in terms of remote monitoring, remote controls, and data collection.
Thank you so much. There we go. Okay. Oh, so fascinating. Okay. So, thank you so much. That was amazing. So next up, Last of our toilet talks is Arthur Davis. Arthur Davis? Arthur has been working with Rich Earth Institute since 2017 and has been running the operations of the community scale urine recycling program since 2019. He loves working with the folks in his hometown community of Brattleboro and the surrounding region to recycle their waste, and with farmers to figure out ways to make use of human waste as a resource.
Thanks a
Hello,
bunch.
Arthur.
All right, so we're kind of at the end of the day, or at the end of the sitting and being talked at day. So I'm mostly going to show you a lot of pictures. I think we've had a number of people, including some people in this room, who I know have come up to Brattleboro and come on various little tours and seen some of these things in person. But I think, there's a lot of talk on the Cape and around, what can these things look like? And I know there's folks like over at the Green Center that have installations of composting toilets and urine collection, but there's a lot of kind of different scenarios and what it can look like. And I thought I would just share some of those kinds of different contexts of what we've done in Vermont. So just kind of as a little bit of an overview, we have permitted 38 different sites around southeastern Vermont for on-site collection, storage, and pump out of source-separated urine. 26 of these are for plumbed systems, so that's kind of mostly what we've been talking about today in various talks. The other ones are more like what the Green Center and Mass TC pilot was a couple years ago, where they had these kind of standalone barrels. But we've really been kind of trending towards most of our systems that we're permitting and installing are plumbed systems. So that's some kind of toilet system or urinal that goes by piping to a tank. We have 20 of these that are either completed or actively in progress. Abe and I have been working on one yesterday and the day before, and we're taking a break to come down here. Most of them are in residential settings, but a number of them are more institutional places, whether that's a school, kind of an event center, or summer camps, or something else like that. And then we've done a bunch of different kinds of fixtures. So some of them are urine diverting flush toilets. Some of them are wall-hung waterless urinals. We have some that are kind of pee-only toilets, basically like a sit-down urinal kind of thing. We saw some pictures of some of those earlier. And then some that are urine diverting dry toilets or composting toilets. You've seen this a couple times before today. To just point out, this is kind of what we're working with in Vermont. We have, this is kind of our simplest version that we're working with that's approved. It doesn't have any overflow. It's not designed to be with a flush fixture. It's really just a toilet piped to a tank with a pump out port and a vent. It has a high level alarm, it has some things that are not allowed in Massachusetts, like air admittance valves. So that wouldn't be in any systems in Massachusetts. And then here's the one you've seen before, which is the one that does have an overflow. That's largely for flush toilets, so that if the flush toilet has a leaky seal, you're not going to flood your basement with dilute pee, which no one wants. So here's a picture of one we did recently. I'll just take this. Here we have our I can't remember actually, the in-feed pipe and the vent are these two. We have our overflow to the sewer here. This is our one-way valve so that nothing can go back this way. And we have our pump out port coming out this way and out this side of the building there. One of the big issues, I would say one of the biggest constraints that we have with doing these is what kind of tank can we fit in someone's basement? Mostly, what kind of tank can we fit through their door or through their bulkhead? So these doorway tanks are really great for that because they are skinny. And they can, because of their shape, they can hold a lot of liquid. This one is a urine diverting flush toilet. Someone put some of their own signs on, which was nice. They sent me this picture. Here's just a bunch of other kinds of pictures of various scenarios. We have another doorway tank over here. Sometimes this person had a really skinny door, so we had to fit 2 tanks. So, I have this kind of system to be able to pump out the 2 tanks separately. Also, we have basements, like many of our basements. Probably many of you have basements that don't have a lot of space left. So the only space that we could put a tank in this basement was on this old stair foundation that was no longer being used. So anyway, we have to get a little creative sometimes, which is kind of fun, if frustrating at times. When I can, we like to use IBC tanks. They have a lot of volume. They obviously are harder to fit in many basements because of their square cubic shape, but they're also really kind of often readily available and cheaper, which is nice. This is another urine diverting flush toilet installation, so you can kind of see it in situ in the bathroom. This was one of the first ones we did. I think Connor was involved in this one for the permitting process. Thank you. All right, so this is one we actually just did this fall. This is for a local nonprofit organization, and so it's totally off-grid. And what we did, it's a composting toilet situation, but for the general public, I'm often fairly skeptical of urine diverting toilet bowls, because people, you get a little kid in there and they sit really far on the front of the seat, and you can imagine what happens next, and someone's got to go clean it up. So this can also go wrong, but I think in general, it's pretty clear, right? And if you're about to make a mistake, you can just kind of shove yourself over. We have a similar situation at a number of summer camps, at 2 summer camps in Brattleboro, and we've had very, very good track record with them. So this one is going to be used mostly not by kids, which we'll see if that's better or worse. But that's kind of a thing that we've been experimenting with recently, is the two seats side by side. See what? Oh, yeah, that's all I got. Lastly, this is kind of, in some ways, one of our more big things that we've done recently, which is that this big event space that was part of this whole barn restoration project was kind of part of this big federally funded restoration project. But we got in with our little piece of bathroom renovation that we added to the project. So this is the finished space here. Here's our tank that we put in the ground next to the barn, and we have 3 urinals in the men's room that drain to here. So it's a 1,500-gallon tank, and this is really our only one that we've done that's like a kind of a big, fully buried system. But it's really it's neat because it really didn't change. For them, it didn't really change anything. It doesn't change anything about the users of the bathroom. No one has to do any other thinking, and yet they're collecting a lot of pee. And I just actually checked it the other day, and it's pretty darn full. So it needs to be pumped out before winter for sure. But anyway, that's all I got. If there are any questions. Oh, yeah. The question was, do we have the capacity to process all of this pee? Yeah, is the short answer. Our pasteurizer that we're working with from Brightwater Tools does about 150 gallons a day. So someone's got real fast math. You can do that math out. But we're currently doing about, maybe 14,000 gallons a year. And, I think we could, at 150 gallons a day, we have plenty of room for expansion there.
And the farmers as well to receive.
Yeah. And especially now that we're kind of concentrating some of it, and we're able to diversify a little bit the end use because of that. Yeah. I saw another hand somewhere. Yeah, Tate.
Yeah, have you, on a residential scale, it seems like there's a trade-off between like tank volume versus like collection frequency. Have you like optimized that to a volume that kind of seems like it works?
Yeah, so the question was about tank capacity in residential settings, like the balance between a bigger tank versus more frequent pumping. I would say in general, I'm trying to aim for at least 200 gallons of capacity. My experience has been that, with 200 to 250 gallons capacity, it's easy. You're looking at about 2 times a year pump out. And obviously that can be different for different kind of settings. I have one family of 4 who's got a IBC tote they're homeschooled and they are home a lot and they pee a lot at home, and that's more like 2.5 times a year, like depending on when I start, either 2 or 3 times a year. So, but you're still looking at no more than 3 times a year, which is a pretty reasonable amount of times to be going to someone's house. Yeah.
Thank you so much.
Nope. Done. Okay. Sounds great. Thank you.
Thank you.